Everybody. Thanks again for participating in this seminar. My name is Edgar Dos Santos, and I work in the technical support team for Latin America and the Caribbean in the New York office. Today, I'm gonna give a brief introduction about midas, and also I'm gonna talk about our software for buildings and general structures, which is Midas Gen. At the end of the presentation, I'm gonna give a brief demonstration so you can have a better feeling of how the software looks in the graphical user interface and how the modeling is done in it. First of all, Midas is the #1 in the engineering software market right now. We have distribution in more than 101 countries around the world. And the company itself is composed of around 450 employees. We've also been very successful in the distribution of our licenses. We've distributed around 30,000 licenses with our different softwares. As you can see here, we have 4 main branches, which are located in Asia, and the one that I am located right now, which is the US. And also we have different resellers, as you can see, which gives us the opportunity of expanding and providing our solutions to more countries. Talking about expansion, these are some of the companies that we work with on the daily basis. As you can see, we have the companies that belong to the top 100 companies around the world, such as Jacobs and URS, and also Thornton Tomasetti for the that work basically with building design and structures. We have 5 main software that we distribute in the New York office. As you can see, we have Midas NFX, which is our mechanical engineering software. We also have Midas Civil, which is specialized in bridges and civil structures. And also we have 2 software for geotechnical engineering, which are Midas GTS and also SolidWorks. GTS is a 3D software and 2D, and SolidWorks is specialized in 2D analysis. And the one that I'm going to talk about today, which is the Midas Gen, which is specialized for buildings and general structures. Midas Gen can handle different types of materials. As you can see, we can use reinforced concrete or steel or composite sections to define and to model our structure. We can also work with different types of structures, such as plant structures, stadiums, arenas, airports, gymnasiums. I mean, Midas Gen can handle like multiple types of structures. It's not only for buildings. As you can see, we've been successful in the distribution of Midas Gen. We've sold about 10,000 copies around the world so far. Some of the projects and application of the Midas Gen have been, we've worked in the Burj Khalifa, which is right now the tallest building in the world. And also we've worked in many other towers around the world. Not only towers, but also we've worked in different plant structures, as you can see here, which gives us more, or as you can see, gives us more liability of how the software has been used around the world. So why Midas Gen? I can tell you that Midas Gen right now has the best graphical user interface among the different softwares. This is how the software looks. When you open it in the demonstration, I'm gonna show you a little bit more. But this is basically the graphical user interface of Midas Gen. Midas Gen handles, it has many different design codes available. As you can see, we have the American code, the ACI, but we also have many European codes, such as Eurocode and British standards, and we also have different Asian codes that we can use in our models. These are some of the results that the reports that we can obtain in midas. As you can see, like the reports are very detailed with the calculations and the dimensioning of the different sections or elements that we are designing. Not only in the design part, but the analysis also, midas-gen is very powerful. As you can see, it handles construction stage analysis, which is very important for the design of tall buildings, but also it handles floor vibration analysis. For seismic zones, we have different types of analysis that midas-gen can handle. As you can see, we have the pushover analysis, and also it handles inelastic time history analysis. We also have the boundary nonlinear conditions that we can apply to the model, in which we can see the behavior of the structures with different boundary conditions. For those firms that are more into advanced analysis, we have material nonlinear analysis and also heat of hydration that can be done in the software. Also, the software handles masonry structural analysis for those firms that do this type of analysis. These are some of the elements available in midas-gen. As you can see, we have a variety of elements that allow us to simulate very closely to the actual structure. We have beam, truss elements, and also we have wall elements, as you can see. And also, this is the list of the applicable boundary conditions that we have in midas-gen. As you can see, we can apply different types of supports and links to generate our model. midas-gen has a feature called optimal dimensioning, which is used for steel structures, in which the software gives us the most economical sections for our design, which reduces the cost of the entire structure. midas-gen also handles seismic zone design. For those countries that are in a high seismic zone, this type of analysis can be done in midas-gen. One of the key things or features that midas-gen have is that it is easy to use. We have something called trim menu and task pane. The trim menu is this part here, in which all the type of analysis or properties that are assigned in the model are listed. And also we have something called task pane, in which, for example, we are performing certain type of analysis and we don't know the steps. The software indicates the steps that have already been done, and also indicates the steps that are missing. So that just in case we don't know how to perform them, the software, as you can see here, puts a check mark on the steps that we already taken into consideration. We also have compatibility with Excel. All the results obtained in midas-gen are can be obtained in table form, and also with 2 simple clicks we can export these tables to Excel, and then we can do our analysis from there. We have something very that is easy to use, is that midas-gen has different interactive views. As you can see, we have something called transparency, in which if we have a very complex structure in the interior, we can actually see the inside of it from for example, from the outside. We also have the walking mode, in which we can virtually walk through the structure and see it from different angles. We have something called identify and activate, in which we can identify a specific part or element or section of the structure, and we can activate it to either assign different properties to it, or just to see this portion of the structure and then analyze it. We also have something called node information, in which we can select a node, and the software will give us the information of it. We have also different views of the results. As you can see here, we have graphical display of displacements, such as displacement contours and also displacement for solids. We also have displacement for contours for diagrams, and we also have all these results can be shown in graphical form, as you can see here. One of the best features of midas.Gen is that it is time saving. We call midas.Gen an all-in-one design software because it handles different types of designs, such as beam and columns, foundation, slab, and wall design. We have another feature called bill of materials, in which the software gives us the total either weight of the materials that we're using, or for example the quantity of concrete that we're using, just for estimating purposes. midas.Gen is very time saving in the modeling part also. It is very easy to model in it, but for example sometimes we're using AutoCAD for drafting, or we use Revit or Tekla structure, and midas.Gen has interface with these softwares. If we have, for example, a Revit file, we can import it to midas.Gen and perform the analysis and design, and then export it back to Revit, and then this will save a lot of time in the modeling and also in the presentation of the project. We have something called report generator that I'm gonna show you later on in the demonstration, but it's basically a Microsoft Word inserted in the midas.Gen, and then I'll show you how easily it is to generate reports with our software. One of the key features of the midas.Gen is the construction stage analysis, and it also takes into consideration the changing geometry, supports, and the loads while we are performing the construction stage analysis. In midas.Gen, we can simulate the construction stages of the structure, and we can do something called activation and deactivation of certain types of loads or elements or boundary conditions to better simulate the construction stages of a building. We can assign them the specific days, and we can see in each construction stage the behavior of the structure. We have time-dependent material properties. These are some of the codes that we have to define creep and shrinkage, and also compressive strength. As you can see, we have the Euro code and the ACI that is mostly used in the Caribbean area. But also, if you don't use these codes, you can also define the properties, and in our user-defined tab, and you can assign these properties to the materials that you're using for the model. Another key feature that midas.Gen has is the results by floor. midas.Gen has a building generator in which we can generate a building just having one floor plan. I'm going to show you later on the demonstration, but these are basically the types of results that we can obtain. All the results can be obtained in a floor basis. For example, story shear or story mass, story drift can be obtained in table form. Also, we have something called definition of modules. If we are working in multiple buildings at the same time in the same model, we can define the different modules and assign them to each part of the structure, and then we can obtain the different results by floor from them. For seismic zone, we have pushover analysis. Pushover analysis can be performance-based, and by FEMA and Eurocode. As you can see here, we also have force and displacement control and objective displacement for design. Also for seismic zones, we have time history and elastic analysis. We have many hysteresis models, as you can see here listed, that allow us to better simulate the behavior of the structure with all these hysteresis models that we have here. We have another feature called drag and drop, in which we can select parts or elements of the structure and we can just drag and drop properties just to assign them to them. I'm going to show you later on in the demonstration that I'm going to perform right now. If you have any questions, you can please ask on the chat box and we'll be happy to answer your questions. I'm going to open the software now so that you can see how it looks like and how the modeling is done in it. This is the graphical user interface of midas. As you can see, it has many buttons as we're used to, like in Windows, with many tabs that allow us to define our model. We also can click on the model view and select different types of buttons from there, which allows and reduce the amount of clicks that we make in the modeling. So I'm gonna start defining properties. So I just have to go to model and properties, where I can define the different materials of the model that I'm gonna generate. As you can see, the software allows us to define different types of materials, such as steel and concrete, and also it has the user defined, just in case we use another, or we can just define our own materials. If I select concrete, we also have a database with different standards in order to just for defining the materials that we're gonna use. As you can see, we have the ASTM, and in this case I'm gonna use ASTM grade 4000. I already have defined the properties that I'm gonna use, but I'm just showing you how easily this can be done in midas. Also for the sections, I go to the section tab, and we have also a database for different sections and the standards that we can use for our model. In this case, I have defined the columns as solid rectangles. These are going to be concrete columns, and I gave it user-defined dimensions for the model that I'm going to create. I also defined the thickness of the walls that I'm going to use in this model. As you can see, it's very easy that you can just move through the tabs to define the properties of the model that you're going to generate. These properties are defined here in the works tree. Right now they're in blue because they haven't been assigned to the model, but these are the properties that I defined for the building that I'm going to create. I'm going to start importing the XF file in order to generate the model. I go to File, Import, and select AutoCAD DXF. Here I will browse the file that I'm going to use. I select it, and then with the different layers, we can assign these layers to different properties. But in this case, I only have these two layers, and I'm going to assign the concrete, the material that I have previously defined, and also I'm going to select the section, which is in this case beam, and I'm going to apply. The software gives us a warning just to make sure that the units using the AutoCAD file are the same as the ones that I'm using right here. Just in case this is not the case, I can change the units right away in these tabs without any problem. Okay, I'm gonna press OK to generate the model. As you can see from the top view, the lines have become beam elements with the sections that I already assigned and the property that I assigned. I'm gonna now generate the columns, and for that I'm gonna select all the elements, this button, and then I'm going to extrude the nodes to generate line elements. For that, I can right click on the model view and select extrude. From node to line element, select the section that I'm gonna use for the columns, and just assign the distance that I'm gonna extrude the columns for, basically the height of it. I apply, and as you can see, I have sections for the columns and also for the beams. If I, for example, want to select this beam and change the property of it, I just have to select it with one click and drag and drop the section that I want to assign to it. As you can see, the section change when I drag and drop it in the model view. I'm gonna go back, and now I'm gonna generate the walls of this building. For that, I'm gonna right click and create element and select the type of element that I'm gonna create. In this case is wall, the thickness that I already defined, and then I'm gonna proceed to model the walls that I'm gonna use. I'm gonna delete these columns from the model, and then I'm gonna proceed to generate the entire building. Press delete. And from there, to generate the building, I go to the building generator, model building, and building generation. Here I specify the distance that I'm gonna copy the floor and the number of copies that I'm gonna use. In this case, I'm gonna copy it 2 times at a height of 3.5 meters. I add it and then apply it, and as you can see, the software generates the model automatically. Then I can generate the story information. I go to building and story, and the software, if I select this button, the software automatically generates the story data. As you can see here, also the floor diaphragm is taken into consideration automatically also. We can see the number of floors in this part if we select this button. And now I'm gonna use the activate by identifying to select the floor that I'm gonna use for the load application. I'm going to pull up a file where I have defined the different load cases, just for the sake of time. Right here I have defined the different load cases for this model. And also I have defined different lateral loads. To define different lateral loads, I can just go to lateral loads and, for example, define wind loads. Here we have, in midas.gen, we have different codes to define these lateral loads that can be selected and then change the properties and then assign them to the model. If you go to the wind profile, we can see the story force and story shear per floor, and also in table form. We can select this graph and use it in the later on in the report generator. I'm going to define the different floor load types. In this case, I have defined the office type of load that I'm going to apply to the model and the different properties of it. As you can see, I gave it values for dead load and live load, and now I'm going to proceed to apply them. I'm going to select the second floor, and I'm going to activate it. I go to the top view, and now I'm going to proceed to apply the floor load. I go to load, assign floor loads, and here you can see the different distributions that midas.gen has for the application of the floor loads. In this case, I'm going to use a two-way distribution, and I'm going to copy the load 2 times at 3.5 meters, which is the height of the different stories. From there, I'm going to proceed to apply the load, and this will be distributed through to the beams, as you can see here. I'm going to apply the load to all the rest of the building, and then from there I'm going to show you how this was applied to the entire building when I copied it. If I activate all, you can see here that all the load was applied to the building. Now I'm going to proceed with the boundary conditions. In here, I just have to right click on the model, boundary, and assign the supports of the building. If I go to the side view and I select the nodes that are in the bottom, I can restrain the degrees of freedom of them by applying these type of boundaries. And as you can see here, this is the symbol of the supports, and each triangle that form the hexagon represents 1 degree of freedom. All the degrees of freedom are restrained, and now I can proceed. As you can see here, all the loads that I applied to the structure and the boundary conditions, the properties, are listed in the worksheet. This gives us a better feeling of how we are progressing with the model. Right now I'm gonna perform the analysis. And if you have any questions, you can just drop it in the question box. You see the analysis is already done, and now I'm gonna proceed and show you the different results that can be obtained in the software. We first check the reactions. We can either select a load combination, but we can also generate the load combinations automatically by selecting the code that we're going to use. In this case, we have also a database for the different codes, and we can select, in this case I'm going to select the ACI for the load combination generation. As you can see here, the software automatically generates the load combinations that are going to be used for the review of the results. In this case, now I can proceed either selecting one of the load combinations, or I can just select one of the load cases and review the results. These are the results for the reaction forces that were applied to the building. And if we click on this button here, we can see and select the load combination. We can obtain these values in a table form. For example, if I select the live load or the dead load and click OK, I can obtain all the values of the reaction forces or the supports in table form, as you can see here. This table, I can export it to Excel just by right-clicking and clicking on Export to Excel. The software will ask me where do I want to save this file, and then I just save it there, and the software automatically exports it to Microsoft Excel. It indicates that the export has been completed, and now I proceed to open the file that I just saved, just to show you how this can be done. As you can see here, this is the same chart that we obtained in the midas gen, but this is in the Excel format. All the results can be obtained in the same way as in table forms, and I'm gonna show you a little bit of the displacement contours, in this case due to the dead load. As you can see here, we can rotate the model very easily, and we can see it from different angles. We can select the load combination and see how the structure behaves with the different loads applied. After reviewing the results, we can go to the design of the structure, in which we can select the code that we're using for the defining it. And then in this case I use the ACI, and now I'm gonna perform the beam design. As you can see here, the software gives us a very good definition of how the reinforcement, for example, should be done in the beam elements that I created in the model. This is some type of report that we can generate in midas gen, in which you can see the graphical definition of the rebars, and also the different bending moment capacities and shear capacities that the beam has. We can also connect this table to the model. If we, for example, select this member, it is shown in the model graphically, so we can have a better feeling of which element we're talking about. The same thing can be done for beams and for columns and walls, but for time reasons I only did it in beams, and this is basically how you can model and design a building using midas gen. I'm gonna go again to the presentation, And as you can see, we're characterized for having a whole development team that is constantly providing services and improving the software. We have two releases per year of upgrades of the Midas Gen, and also we're characterized by the consulting that we provide. We have something called e-business, in which we provide 24 hours technical support, and also we provide free training. The training is done in a session like this, in which you can share your screen or we can share ours, and then we can help you in any problem that you have with generating the model or anything that you need. We also have the technical support, in which you can contact us at any time, and we provide our services. We are characterized for providing the engineering services and solutions for our users. Thanks a lot for your time and for participating in this seminar. If you have any questions, you can feel free to contact me at e.santos@midasuser.com. Or if you have any other questions, you can ask in the chat box.